Okay, good morning everyone. So I'm here at LPU Cavite. Na-miss ko yung LPU guys. Kaya dito ako ngayon. So I hope you can see me and you can hear me clearly. Okay, audio check and video check. I hope that you can see my uh, glass board, yung video pala. Now we're going to talk about yung two remaining topics for solving first order differential equations. So yung una muna is the integrating factor. Although we have dealt with integrating factor in solving linear equation. Now let's focus on, solving non-exact differential equation by introducing an integrating factor to that equation para ma-solve natin. And the next one will be solving for Bernoulli's differential equation. Okay, yung Bernoulli's naman is a generalized case of linear equation. Okay, so let me present first the technique. How do we determine that integrating factor? There are actually two ways. You can determine the integrating factor by inspection, and the next one is by formula. But we are going to use the formula in finding for the integrating factor. Okay, again, so we can solve non-exact DE by multiplying an integrating factor to make it exact equation. So we have two cases. Okay, now let me write first yung dalawang cases natin. So if, taking note that m dx plus n dy equal to 0, be a non-exact DE. I hope you can see this one. So case number one, if, diba, we determine if it's exact or non-exact, diba, by utilizing the test for exactness, right? So what we're going to do is, if we take the difference, the partial of m with respect to y, and minus the partial of n with respect to x, if the difference of these partial derivatives divided by n is equal to a pure function of x, then the integrating factor that we are going to use is I equals e raised to the integral of f of x times dx. Again, I here means integrating factor. This is by formula. Now, case number two, if the difference, the partial of m with respect to y minus the partial of n with respect to x, divided by m, and the result is a pure function of y, then the formula to determine the integrating factor is e raised to the integral. It's negative actually. So it's negative the integral of the function of y times dy. So these are, the formulas to utilize, provided that the condition is met. Okay. Now, so how did this formulas, you know, how did we come up with this formula? It's actually by introducing this integrating factor. We multiply this to the given non-exact DE, and then we, of course, the same derivation for that we used to arrive at the, of course, the testing for exactness. That's why we have these formulas. So di ko na siya pinakita. I did not show here the derivation for these formulas. Well, anyway, so let me explain again these conditions. Okay. Now, this is the form of the DE. M dx plus n dy. M is an expression or a function coefficient of dx, and n is an expression coefficient of dy. Okay, take note. Now, we can only do this if the partial derivatives are not equal. So we take the difference, partial of n with respect to y minus partial of n with respect to x, and you can actually take a look at the resulting difference. Now, the question is, what is the appropriate coefficient that I will be dividing that difference that will result to a pure function of x or a pure function of y? Okay, you can actually do by inspection. You can actually check the value of the m and n. So if you divide m, the resulting equation should be function of y. If you divide it by n, the resulting equation should be a pure function of x. Okay, so you need to practice, so that you can be able to determine. So another hint for this one is, di ba n is a function or say a coefficient related to dy, right? So just think of it as a function of y. So if you divide this difference by n, the coefficient um, associated dun sa dy, you're just canceling y, di ba? So dapat yung matitira, what will remain there is a pure function of x. Okay? Do you get the idea? N is associated with y. So if you divide the difference by this n, the resulting function should be a pure function of x. Okay? Now, if you divide the difference by m, okay, m is a coefficient or function associated with dx or the x variable. So it's as if you are dividing the difference by x. You're trying to cancel the function of x there. So what will remain is a pure function of y. Okay, do you get the idea? Now, um, the question is, so lagi bang nangyayari is that are these conditions always are happening? So not all the time. So if that's the case, then the DE cannot be solved by making it an exact DE. So there are other ways or techniques that you can solve that differential equation. Okay, but for cases like this, if these conditions you know, are met, then you can actually utilize the formula. Okay? Any questions so far?
None.
None? So the idea for this one is we determine the integrating factor, we multiply the integrating factor to the non-exact DE, and that DE will become an exact equation. So once na naging exact na siya, we can utilize the shorthand method to determine the solution. So you don't need to do the side is na steps to follow the side is steps to solve an exact equation. So we use the shorthand method. Okay, before I forget, so take note that we have a negative sign here. So why is that, sir? Okay, as you can see, the order of the partial derivatives. Okay, take a look at this. So partial of m is the first one, right? Being sa yung na the next term will be partial of n. So we always utilize these difference. If you want to make this positive, you interchange their positions. Okay, that's the idea. But since we are trying to verify or to check at the given equation whether m or n is appropriate to be divided in that difference. So that's why we utilize the same order, and then you just change the sign for this particular condition. Okay, that's why
Sir,
negative siya.
sir,
Yes.
sir, if you change the sign, if you change the order and the sign changes to positive, do you still get the same answer if you solve, if you have a question?
Okay, that's why I have explained to you that
Sir, did you
this.
get my question?
Yeah. What's your question again? If you interchange.
If you interchange it and it becomes positive at I equals to exponent, do you still get the same answer when solving?
Yes.
It doesn't become a negative in the answer or become a positive. It's gonna be the same.
Mm, in your condition here, you interchange the position. Did you
Yeah.
interchange the position? Yeah. If you interchange this partial of n with the first one, and then Yeah, partial of n will be the second one here. And then the resulting function, you need not to, put negative. So you just copy the sign of this one. Okay?
Okay.
Whatever the sign of this function. So you just copy. If you start with partial of n for this case. Okay, but if you utilize the same order as to what I have written here, then if you divide the difference by m and it resulted to a function of y, so you must put a negative sign in the formula. Okay, so if the result here is negative, you multiply that by negative here, and it becomes positive. Yeah, that's the case. Okay, I'm just telling you other options so that if you missed or if you want to put partial of n first, then you should take note that you should copy the sign of this function here. Okay, first example, solve x dy plus y dx equals x times y times dx. So this is a first order differential equation. And what we'll do now is to arrange the given equation into the form m dx plus n dy equal to 0, meaning this part of the equation will be transferred to the left-hand side. Okay, let me just rewrite solution. So this will become, okay, so we arrange that into this format. So dx, if you transpose this, it will become negative. So, and then factoring out dx, we have, okay, y minus x times y dx plus x dy equal to 0. Okay, do you follow? So transposing this to the right to the left hand side will become negative. That's why. And then you have the same dx. You factor out dx. So you have y minus x times y plus, you copy this one, x dy equal to 0. Okay, now that we have this differential equation, the next step will be to determine or to test the dE for exactness. Okay, as you can see, this dE is uh, I think this is a separable D, but you can actually make this an exact if you were able to determine or to solve for that appropriate integrating factor. Now, we test the D for exactness. Your M here is equal to, okay, let me know if my audio have some issues, okay? Because earlier we have experienced, some technical difficulty. That's why if you have, experience or if you listen to my audio being distorted or, yeah, the interruption. So please let me know. Now our m here is the coefficient of dx. So you copy y minus x times y. How about our n? Our n is the coefficient of dy. So that is x. We take the partial derivative of m with respect to y, meaning x is held constant. Okay, so we differentiate this with respect to y, that is 1. We differentiate this one, so we copy negative x, differentiate y with respect to y, that is equal to 1. So we have this resulting partial derivative. Now, for this one, take the partial of n with respect to x, and y is held constant if there are, variable y present in the expression. So there's none. So that's why we take the partial of x with respect to x equal to, and that is equal to 1. Okay, so what have you noticed? The partial derivatives or their partial derivatives are not equal. Okay, partial of m with respect to y is not equal to partial of n with respect to x. So the next step is to find for that integrating factor, if it's possible that this equation has an integrating factor. Again, I said earlier that there are two ways to determine the integrating factor, by inspection and by using the formula. Now we are going to utilize the formula. And by doing that, we first test from that condition. So we take the difference. So if the first step is take the difference, partial of m with respect to y, we subtract, okay, partial of n with respect to x. Okay, so We do not decide yet if we're going to divide the difference by m or n. It depends on the resulting difference. Okay, so later. Okay, we'll think about that later. So partial of m with respect to y is 1 minus x. Okay, and then the partial of n with respect to x is equal to 1. So you subtract that. So minus 1. So what's the result? 1 minus 1 is 0. So you have here negative x, right? Do you follow? So you have negative x. Now you are going to decide what's an appropriate, expression to divide. Is it m or n so that we have a pure function in the result? Okay. Remember that a constant could represent function of y or function of x. Okay, so if we divide m to this difference, do we cancel one of the variables there? So take a look at this one. Y, you can factor out y here. So y times 1 minus x. You divide this difference, negative x divided by this one. It still contains variables x and y. It still contains, right? Right? So m
Yes, sir.
is not an appropriate function to divide the difference. So take a look at n. If we divide n, so again, remember, if we divide n, since n is associated with dy, so you are canceling y, the resulting function should be a pure function of x. Okay? And if the result is a constant could represent a function of x or a function of y. Okay? Now, we divide n. So that is x. Negative x over x is equal to negative 1. Yeah, an integer. So this is, of course, if we divide the difference by n, okay, we are canceling y. So the result should be a pure function of x. So this becomes f of x. So we use this to determine the formula, the integrating factor. And what is the formula? I is equal to e raised to the integral of f of x dx. And what is f of x? That is equal to negative 1. So e raised to negative integral of dx. So the integrating factor, we're going to multiply this dE will be e raised to negative x. Okay, to make the dE an exact dE. Okay, do you follow? We don't need to test again for exactness. Yeah, surely if you multiply this equation by this integrating factor, it will be an exact dE. So earlier I have shown them that the resulting partial derivatives are equal. So to save time, you can actually do that at home. Okay, now let's proceed to solving this equation. Anyway, any questions?
Wala po.
None. Okay, let's proceed now to multiplying this first order dE by what we have just determined, the integrating factor. So we have e raised to negative x. E raised to negative x, yeah, multiply the entire equation. And y minus xy times dx plus x dy equal to 0. So once we multiply this equation by the integrating factor, this becomes an exact equation. Okay, so this becomes e raised to negative x times y minus e raised to negative x times y, yeah, times dx plus x e raised to negative x dy equal to 0. Okay, so we're able to multiply each term by the integrating factor. The next step is we utilize the shorthand method. If you remember the formula, how do we use that? So integral of m dx, the first term should be, okay, you let, of course, or you put y, or the y is held constant, okay? And then plus. You integrate n dy, the terms only without those that have no x in it, okay, equal to c. Since here dy times a function of x, so this term can now be cancelled, okay, if you are going to utilize this formula. So we integrate the first term. Y is held constant, so you factor out y, and then you integrate e raised to negative x times dx here in the second term. So you have, okay, minus y will be put before the integral symbol. So integral of x e raised to negative x dx. And this term here, we do not integrate this one because it has a variable x in it. So 0 na yan. Equal to, okay, just, yeah, plus 0 equal to c. Okay, so we integrate this one. First term e raised to negative x dx. So we have the formula for that. Okay, remember our u here is negative x. So the du should be negative dx. So you have a neutralizing factor there. So you multiply negative 1 and then neutralize by negative 1 outside. Okay, here naman you can use integration by parts. Okay, algebraic function multiplied to exponential. You can utilize the shortcut, the shorthand formula. Although you have this guide, integral of u dv for integration by parts. Okay, it's the product of u times v minus integral of v times du. Okay, remember this one. Or you can utilize the formula. Okay, I mean the shortcut u dv. You can only do this one if one of the factors is an algebraic function. You cannot use this one if the given integrand contains exponential multiplied to trigonometric function. Trigonometric function multiplied to um, or exponential multiplied to inverse trigo, or ln, logarithmic function. So you can't utilize this formula. But here, since we have x times e raised to negative x, so our u will be the algebraic function x, and our dv will be e raised to negative x dx. On the left part of this table, we differentiate, okay? And on the right part of the table, we integrate, okay? So differentiate until it becomes 0. So differentiate x, 1, differentiate 1, 0. Okay, now we integrate this part. Okay, e raised to negative x, and that will become, you have a neutralizing factor. So negative e raised to negative x, integrate again. So you have negative times negative, it becomes positive e raised to negative x. Okay, and what will happen now? So this is dv. If you integrate this one, this becomes v. So the product of this one is u times v. This one is u times v also. So you have the sign plus and you have minus. Okay, so let's continue. We have utilized this technique in integrating like this integrand yan, by parts. Okay, we erase this first, and then we write the resulting integral here. So the result for this one, of course, integral of e raised to negative x dx will be what? So e raised to u, this should be negative. Of course, you neutralize outside, so that becomes negative e raised to negative x. Okay, so the answer for this one will be copy y multiplied to e raised to, of course, negative x. And then we copy minus y. We integrate this one, and we already did here. So times the product of this one, u times v. So plus yung sign, the negative here. So minus x e raised to negative x. And 1 times e raised to negative x is e raised to negative x times negative. So you have minus e raised to negative x. Okay? Now, for the last term, wala na to, di ba? So equal to c ka na lang. We distribute this one, so we have minus y e raised to negative x minus minus, so you have plus x times y e raised to negative x minus times minus, so you have positive y e raised to negative x equal to c. Okay, there are similar terms. Minus y e raised to negative x plus y e raised to negative x. We can cancel this one. So the solution will be x times y e raised to negative x equal to c. So this is now our general solution, or you can multiply both sides by to make this a positive exponential function. Yung exponent dito. So x times y e raised to negative x equal to c. Multiply both sides by e raised to positive x will eliminate this exponential function on the left-hand side. That's why we have xy equals c e raised to positive x. Okay, so that's it. Now let's move on to example number 2. Solve 2xy squared minus 2y. So the first term is, this one is our m, yeah, plus 3x squared y minus 4x. So this function is associated with the dy. This is our n. Okay, a first order differential equation. Now we try to test the dE for exactness. So we take the partial of m with respect to y. Okay, what is our m? 2xy squared is the first term. So x is held constant. We copy 2x. We differentiate y squared with respect to y. And that is 2y. For the second term, we have minus 2y. Differentiate with respect to y will give us minus 2. So the partial derivative of m with respect to y is equal to 4xy minus 2. How about for this term here? So take the partial of n with respect to x. So y is held constant. Now we copy 3y. So 3y, and then we differentiate x squared, that is 2x. For the second term, you have minus 4x. So we have minus 4 as its derivative. Okay, if you rewrite this one, so we have 6xy minus 4. Okay, what have you noticed? Their partial derivatives are not equal. So it means that this is not exact or a non-exact DE. Okay, so what are we going to do now? So we take a difference of these partial derivatives. So partial of m with respect to y minus partial of n with respect to x. So we don't know what to divide yet, m or n. So whichever is, of course, appropriate later. So taking a difference, we copy this one, 4xy minus 2. And then we subtract the partial of n with respect to x. So copy this one. So minus 6xy minus minus. So this becomes positive 4. Okay, so we divide by what? Okay, we don't know yet. 1 over what? Of course, we perform this first. 4xy minus 6xy. This is negative 2xy. And then combining the constants, minus 2 plus 4. So you have positive 2. Okay? So what have you noticed? You can actually factor this one, diba? Factor the negative sign. Negative, yeah, 2xy minus 2. So observe the resulting, partial derivative. I mean, here, the m and n, which is appropriate. So for the first, yeah, for m, we can say we can factor out one of the y's there, diba? Y times 2xy minus 2. And for here, for n, you can factor x. So x, so you have 3xy minus 4. So which one is appropriate to divide in the difference? Okay. Of course, you can see the similarity, right? If we are going to divide the difference by m, you know that m is associated with dx. So you're like canceling x there. So the result should be a pure function of y. Okay, do you follow? If you divide the difference by m, the result should be a pure function of y because m is a function of or associated with dx. If we divide the difference by n is associated with dy. So it's as if you are canceling y there, and the result should be a pure function of x. Okay, do you get the idea on what to choose, whether m or n? Okay, so let's try now. Divide by m. These difference by m. So m is, we copy y, the factored form. So y times 2xy minus 2. Okay, so I'm going to rewrite so that you can see, how I cancel. So this one, this difference will be written into this format. So minus 2xy minus 2 divided by m, which is in factored form y times 2xy minus 2. We can cancel 2xy minus 2, and the result is negative 1 over y. So what have you noticed? So tama lang din, di ba? If we divide the difference by m, the result should be a pure function of y. And in this case, function of y naman kilalabasan. So this will become g of y. Now the next step is to determine the integrating factor, and the formula for that will be I is equal to e raised to the negative, okay? So we use this order of, finding for the difference. Yeah. So integral of g of y times dy. Okay, so this will be e raised to negative of the integral of negative 1 over y times dy. Negative times negative, this will become positive. So integral of dy over y is equal to ln of y. Therefore, the integrating factor is equal to e raised to ln of something is equal to that something. So the value of the integrating factor is y. Now that we have the integrating factor, we multiply the given equation by this integrating factor to make it an exact equation. Okay, we copy the given DE. So this is 2xy squared minus 2y times dx, okay, plus 3x squared y minus 4x times dy equal to 0. We multiply the entire equation by the integrating factor y to make this an exact equation. So the first term will become 2xy cubed minus 2y squared times dx plus, here you have 3x squared y squared minus 4xy times dy equal to 0. Now, utilizing the shorthand method for solving the exact equation. So again, we don't need to show the testing for exactness. Surely this is an exact DE. You already multiplied the integrating factor. Again, the formula is integrate mdx, taking note that y is held constant, and then integrate only this term, okay, the ones without x. Okay, it means that you are integrating a pure function of y. Okay, if there are variable x there, if there are variable x present in this term, so you do not include that in your integration. Okay, so for our first term, y is held constant, so you copy 2y cubed integrate x times dx. Second term, so you copy 2y squared held constant, integrate dx. And for this one, you have a variable x present, variable x, so you have to not include that one. So plus 0 equal to c. Integrate this one, so you have 2y cubed. Integral of x dx is x squared over 2. Integrate this one, so 2y squared. Integral of dx is x equal to c. Cancel 2 here, so the answer is x squared y cubed minus 2xy squared equal to c is your final answer. Or you can write in factored form where you can factor out what? X. You can factor out y squared. And then here you have xy minus 2, okay, equal to c. Okay, whichever. Any question?
Yes, sir.
Now let's proceed to the next topic, which is the Bernoulli's differential equation. So this equation is actually a generalized case of linear equation of order 1. Okay, now what is the form of, or what is the form of a Bernoulli's equation? So take a look at this one. dy over dx plus p as a function of x times y equals q as a function of x times y raised to n. Okay, so y generalized case. If you take a look at this equation, it has y raised to n. So this y raised to n makes this distinct from linear equation. So if there is if there's y raised to n is removed, it's actually linear in terms of the variable y. Okay, so we can actually put this equation in. We can make this linear. Okay, how? By doing substitution. Okay, so how do we do that, sir? Firstly, you are going to eliminate y raised to n at the right-hand side of the equation. So how do we do that? We multiply the entire equation by y raised to negative n, or we divide by y raised to n. Okay? Now let's do that. So let me copy. Okay, dy over dx plus p as a function of x times y equal to q as a function of x times y raised to n. Again, we multiply the entire equation by y raised to negative n, or divide it by y raised to positive n. That's the first step. You remove y raised to n there. So this becomes y raised to negative n dy over dx plus this becomes, yeah, p as a function of x. So y times y raised to negative n is equal to y raised to 1 minus n equals q as a function of x. So yeah, this is the resulting equation after we multiply it by y raised to negative n. Now the next step is to let a new variable to represent this expression here. So we let z equal to y raised to 1 minus n. Okay, and what's the next step? It means that we are going to replace the variable y in this equation so that we have variables x and z in the linear equation later if we are going to arrange it. Now differentiate this one. So dz is equal to, differentiating this, so we have 1 minus n. Okay, power formula for differentiation. So y raised to 1 minus n minus 1. So what happens there? So you have negative n times dy. Okay, so you are going to replace y raised to 1 minus n by z. And as you can see here, on the first term, you have y raised to n dy. So you can put this equation into that format. So y raised to negative n dy, dividing both sides by 1 minus n will become dz over 1 minus n. Okay, now we plug in this equation. Okay, so y raised to negative n dy is equal to what? So we copy 1 over 1 minus n dz, okay, over dx. Can you see, guys, from here? I hope you can see.
Yes,
Okay, we
we
have
can.
plus p as a function of x, and this becomes z equals, of course, q as a function of x. Okay, are we good here? I think, yeah, we can arrange this into standard form. So how? We eliminate 1 over 1 minus n here. So by doing that, we need to multiply 1 minus n, the entire equation. So this becomes dz over dx plus, okay, 1 minus n, p as a function of x, okay, times z equals 1 minus n times q as a function of x. So this is now linear in terms of the variable z. Okay, that's how you do Bernoulli's equation. So we did substitution to make this linear. Okay, and later on, of course, you have to bring back the original variable, the value of z, which is y raised to 1 minus n. So this n here represents an integer, okay? It could be positive or negative, yeah. Now, I think we're ready for an example. Okay, first example, solve dy over dx plus 3y over x equals x raised to 4 times y raised to 3. So this is actually Bernoulli's differential equation because it has y raised to 3 at the right-hand side of the equation. So the first step for this to be solved is we are going to eliminate y raised to 3 at the right-hand side. So we copy first. So dy over dx plus 3y over x equals x raised to 4 y cubed. We multiply both sides of the equation by y raised to what? Y raised to negative 3. Okay. So this becomes y raised to negative 3 dy over dx plus this becomes 3 over x. Y times y raised to negative 3 is y raised to minus 2. 1 minus 3 is negative 2. Okay. Equals x raised to 4, a pure function of x. Okay. We were able to eliminate y cubed there.
Why negative?
Yes?
Sir, why negative?
Y negative? Y raised to negative
Yeah,
3?
yeah,
Yeah.
why negative?
So I said earlier that you can actually multiply y raised to negative 3 or 1 over y raised to positive 3. Okay, they're the same, right? So you can multiply to eliminate y cubed. Do you follow, guys? Oh, multiply this one, y raised to 3 times y raised to negative 3. What happens? Y raised to 3 minus 0, right? Oh, this becomes 1. So remove na yung y raised to 3. Okay? I hope you
Yes,
understand.
sir.
Now that we have this equation, we're able to put the right-hand side as a pure function of x. Now we let a new variable z equal to y raised to negative 2. And then we differentiate that. This becomes negative 2 y raised to, so minus 1, okay, negative 3 times dy. So as you can see, replacing this by z and this one, y raised to negative 3, you can see it from here. So we divide both sides by negative, yeah, negative 2. So this becomes negative dz over 2, and this becomes y raised to negative 3 dy. Okay, now we plug it in here. So this becomes y raised to negative 3 dy is equal to negative 1 half dz over dx. Second term will become plus 3 over x times z equal to x raised to positive 4. Now, the next step is to put this equation into standard form. How do we do that? We make this 1 in nasa dz over dx natin. So we multiply both sides of the equation by negative 2. And this will become what? Dz over dx. The second term will become negative 6 over x times z equals negative 2x raised to 4. Okay, now this is now linear in terms of the variable z. Okay, now the next step is to determine the integrating factor. So as you can see, your p as a function of x here is equal to negative 6 over x, and your q as a function of x here is equal to minus 2x raised to 4. So we utilize this p as a function of x to determine the integrating factor. So e raised to the integral of p as a function of x, okay, times dx equals e raised to minus 6 integral of dx over x. This becomes e raised to negative 6 ln of x, or e raised to ln of x raised to minus 6. So the integrating factor is x raised to negative 6. Okay, now we erase this first here, or we can actually utilize this part. Now what we will do is we multiply the standard form, which is dz over dx. We can see it from here. We copy this. This is the standard form. Minus 6 over x times z equal to minus 2x raised to 4. We multiply the entire equation, this standard form, by the integrating factor, which is x raised to negative 6. And this becomes an exact equation. Now, we said that the left hand side is always equal to the product of the integrating factor, x raised to negative 6, and the dependent variable, in this case, letter z, or the variable z. And the right hand side is equal to the integral of q as a function of x, which is minus 2x raised to 4, times the integrating factor, x raised to minus 6 times dx, plus the constant of integration. Okay, we can erase this part. Okay, now we integrate this one. We copy x raised to minus 6 times z equals, factor out minus 2, x raised to 4 times x raised to negative 6 is x raised to negative 2 dx plus c. Okay, power formula. Negative 2, integral of this one is x raised to negative 1 over negative 1. Okay, plus c. Okay, now we copy x raised to minus 6 times z. Negative 2 times negative 1, so you have positive 2. X raised to negative 1 is equal to 1 over x, so 2 over x plus c. Okay, general solution supposedly, but you know that z is equal to y raised to negative 2. So you plug it in here. So x raised to negative 6 times y raised to negative 2 is equal to 2 over x plus c. Okay, that's it. Now we were able to bring back the original variables, y and x variables, so that we put now the exponents into a positive 1. So you multiply both sides of the equation by, of course, x raised to positive 6, and here to make this positive, y raised to positive 2. So this becomes 1 equals, of course, 2x raised to the fifth y squared plus c x raised to 6 y squared. Okay, now your answer will be 1 minus 2x raised to 5 y squared equal to cx raised to 6 y squared. Or you can arrange it in a form that you can factor out one of the variables there. Okay, so that's it. Questions?
Goodbye. Right.
Yes? None?
Sir, dun sa pinakadulo, sir, pwedeng yung silang yung nasa huli.
Hmm. Where? Where?
Yung final answer, sir. Yan, sir. Hindi po ba maaalis yung mga x raised to 6 dyan?
Hmm. Kung gusto mo, pwede naman. So, pwedeng, yeah, 1 minus 2x to the fifth, sorry, y squared over x raised to 6 y squared equal to c. Naka-rational expression. Okay?
Salamat, sir.
Or pwedeng ito rin, di ba? You can make this 1 over x raised to 6 y squared minus 2 over x equal to c. Okay, there are many possible answers for that. Unless
Okay, sir.
you're asked to solve for y, so you factor it. If you want to solve for y, okay, say for instance, solve for y. Okay, so from here, solving for y, where are we? Factor, or from here na lang siguro. Yeah, from here. So this is 1 over x raised to 6 y squared equals 2 over x plus c. Now you interchange the cross multiply. So you have 1 over x raised to 6, 2 over x plus c equal to y squared. So y is equal to square root of 1 over, or here you have x, right? Makancel yung isang x dito. So you have cx, right? Makancel to. So raised to 5. Ta-da! So the answer is 1 over x raised to the fifth 2 plus cx. Okay,
Okay, sir.
solving for y. There are many possible solutions. Okay, so I think, yeah, that's it for today. I can still give you some more if you want, but anyway, I'll just give this one for your problem set. So I'll be posting your problem set maybe tomorrow after I finish the discussion with the other two sections. Okay, so I'll
Sige
be
po, sir.
posting this later, the video. Thank you guys.